Kau sudah siap ke tutup laptop ni?
Yang hari tu kan?
Ya.
Saya belum buat susah. Alah. Kau sudah? Sudah, tapi ada yang belum buat lah. Boleh lah tu. Janji kau share je lah.
Ya, biarlah. Ya, nantilah aku share.
Boleh lah. Sekejap dah.
Hai, hijab yang pelak. Mau masak ni.
Bang. Nantilah aku panggil kau kalau sudah masak.
Oke.
Bye.
Bye.
Aku pun mau air dulu lah. Uish. Kenapa boleh mati garam ni?
Hi, Marina.
Hi, I'm Nur Fadil.
Hi, I'm Mr. Ted.
When teaching the topic of alternating current, we find it very difficult to explain the definition of root mean square current or IRMS.
Okay, class, do you still remember about the definition of root mean square current? Do you still remember about the definition of root mean square current? Ask me. What is the definition of root mean square current? Word there. Special word that relate to this. Huh? Ayo.
Students are forgetful about the definition of root mean square current because they just memorize from lecture note. To address the problem, we have created AC-Duino Kit. This kit uses an Arduino microcontroller where its value can be displayed in an LCD and also in the laptop screen. ACS712 current sensor is used to collect the current reading. We have brought in the real-life household appliances such as vacuum cleaner, wardrobe, toaster, cloth iron and water kettle to be measured their current and power values. We have also used two LEDs, green and yellow, to differentiate between high-powered or low-powered electrical appliances. The AC graph shows both positive and negative values going up and down. Here you see the vacuum cleaner has initial spike of current. Wardrobe also shows initial spike of current because they use more power to turn the motor initially, but low power later on. Toaster that based on heat does not show the spike of current, but it shows big graph all the time, means it used a lot of power to generate heat. Water kettle that based on heat also has no spike but big graph all the time. This kit shows the difference of AC graph between heat and motor. All the AC graph shows high frequency because alternating current operate on 50 to 60 Hz as shown in the label. Here for the cloth iron, we are very surprised when the AC graph suddenly dropped to 0 because the thermostat cut off the current when it reaches a certain temperature. AC-Duino Kit clearly shows the importance of root mean square current in our daily life because RMS value is the value that we use to calculate the power consumption of all our electrical appliances. Green LED, low power, 450 watt. Green LED, low power, 330 watt. Yellow LED, high power, 1400 watt. Yellow LED, high power, 1700 watt. Yellow LED, high power, 2000 watt. Appliances based on heat uses more power than motor, and water kettle has the highest power consumption. We have also integrated IoT technology by using ESP32 and Blink app. Through Wi-Fi or Bluetooth, the current and power values can be sent to the mobile devices wirelessly. The LED can also be programmed in the Blink app. High power, low power. Do you still remember the motor has spike of current to turn the motor initially? High power, low power later on. High power. Iron which based on heat always has high power.
So it so fast. You see, ada positif, ada negatif value. Betul tak?
Yeah.
Betul tak? It's very big value. Yeah. And can you check the power? And can you see? Yeah. Can you see?
Oh, 50 to 60 hertz.
50 to 60 hertz. 50. Oh. The frequency is the same. Yeah. Look at what is the frequency, class? What's it?
Yeah, 50 to
60 to 60. Yeah. Yes. Let's start. 1, 2, 3. Tali. It's hot, sudah ada? See that? The room is spare current? Berapa?
Sudah sama.
Yang mula-mula 2000 pergi 300.
I think the most meaningful thing that I learned is I now know which type of electrical appliance that use the most energy. For example, in our house, things like toaster and oven, things like that use heat, use more energy to power it. Also now I understand what the label say on the electrical appliance. For example, the 50 Hz label on the appliance. Now understand, it show us the frequency of the current on the appliance. Today I understand how important IRMS is, the root mean square current. The root mean square current actually are used to calculate the average power. So I think it's a very good experiment.
This project actually also helps me to understand like physics is not just something we learn from books and everything. It's something you can apply in life.
Lepas tu, dengan eksperimen tersebut, sekarang baru saya sedarkan apa pihak sekolah sangat mementingkan pelajar agar tidak menggunakan barangan elektronik yang menggunakan banyak tenaga seperti setrika ataupun water heater. Sebab barangan tersebut diorang menggunakan banyak tenaga dan juga diorang consume banyak power yang dapat membuatkan short circuit berlaku.
Because true physics is not just all the formulas and all the calculations, it's also how you build stuff by using physics.
Yeah.
So especially in the showcase of the Arduino, we can see that it really has a great impact on us. So I really support this.
So what?
This project Arduino engaged me more to explore more my hobbies and the things that I like about the technology. So I plan in my future that I want to take electrical engineering as my degree major. I want to be a programmer electrical in the future.
So